Welcome to the next module of the Camunda BPM online training. Today we want to have a look at the architecture of the engine and how to embed the engine within your architecture. We just start with the engine itself. If you look at the engine, it's a Java program, so it's completely written in Java. Like simple jar, the Camunda engine jar. This implements the whole state machine, the BPMN 2.0 language, and all these kind of things. So that's a pretty thin Java layer. We use a relational database for persistence. So we use JDBC in order to talk to the database. And to not use JDBC directly, we use a small layer in between, which is an Apache project. It's called MyBetis. It's open source as well. It's an Apache license. And this is, you can imagine it like not being a full-blown JPA or mapper like Hibernate or Eclipse Link or whatever. It's more or less like wrapper around the JDBC and the SQL statement. So we basically have an XML part of it where we configure all the SQL statements, so we can easily have a look there, or if you want to tune or do something like that. It's pretty easy with MyBetis. So we use that in order to talk to the database. Above the BPMN 2.0 engine, we have the Java API. You already saw that in the overview. If you use the public API, you use your thread you provide, go through basically use a command pattern inside of the engine and go through a chain of interceptors in order to do, like, for example, transaction management, and then go onto the core engine. And that's something you actually can easily see. So if you go into some test case, we use the one from the overview. So if we go in a test case, go into the runtime service and look at the start process instance by key method. You go into the implementation and you see that we always use a command executor and we use command objects to do the real logic. So that's what I mean. So that allows us to hook in a lot of interceptors and do a lot of things in between. Okay. Yeah. So this is what we use here. There's one active component we have on board in order to execute, for example, timers. So if we look at the Twitter example again, we added a timer. So this basically means some component has to be active and polling for that timer in order to execute it when it's due. And that might not be in 10 seconds, it might be in 2 weeks or whatever, 3 months. So there's the so-called job executor, which basically polls periodically on the database and checks if there's anything to do. Okay, so that's basically the engine. If you have a look at it in Java, you can see that easily. So we look at the dependencies. We have that actually not a lot. We use the engine jar. Okay, I have the CDI stuff separately here. And if we look at the transitive stuff I get, with the engine, I get basically MyBetis. So that's the Apache MyBetis. We use Yoda time. That's maybe interesting as well. And we use Spring to set up the engine in the test cases. So that's something you could skip. We don't need that actually. And we use common email if you send emails directly via the engine. So you could skip that as well. Okay. So that's actually pretty nice, I think. Pretty clean, pretty small footprint here. If you have that engine, you can basically start it up in any environment you like. So for example, we do that live. For example, I could do that in a pure Java environment. So I'm in a public static void main. What we can do is we have a so-called process engine configuration class. Okay. So if we look at that, process engine configuration class, that's basically the class where you can set all the configuration options for the engine. So for example, what database you use, or the JDBC connection, or some stuff about the job executor, if it's active or not, and some more, okay? We don't care about the details at the moment. The important thing is if you want to configure something in the engine, the process engine configuration is a good place to search for. And we have a couple of subclasses of the process engine configuration in order to basically to have some specifics for environments. For example, if we run in a JTA environment, like transactional, then we have the JTA process engine configuration. If we run in a Spring environment, we have the Spring process engine configuration. And we have a couple of standalone process engine configurations, for example, the standalone in-memory process engine configuration. That's something we can leverage. So that basically sets database schema update to create drops. So the database is created when the engine starts, and we set the JDBC URL to an in-memory H2 database. So that's pretty straightforward, I guess. So we can leverage this one to easily start up an engine. So I just instantiate the configuration. And then I can say build process engine, and that's it. Okay. So now I have a process engine. Actually, the process engine, it's not much to start up here. So there's not a lot of things going on in the background. There's one thing you should keep in mind. It basically sets up a database connection, and it might start up that job executor, which in the default Java implementation is a thread pool, which is started up in the background. Okay. But now I have a process engine. I can use the process engine as we already saw. So I can use the services, the repository service, for example, to create a new deployment. So I want to deploy my Twitter process to my in-memory database. Okay. I add something from the class part, which is my Twitter demo process. And I deploy it. So that should be everything to deploy the process on the engine. And now I can say process engine get runtime service, start process instance IT, Twitter demo process. Yeah, that's it. So that should already be sufficient to start an engine. Check that. Okay, at least we don't see any error. Okay, so it starts up the database, it creates the stuff. Yeah, pretty straightforward, I guess. We could do a system, maybe that's nice to see that something's happening here. Started okay, that's it. So that's pretty straightforward, I think. It's really easy to do. That engine you could now embed in basically in different applications or environments. So think of the engine in this step as a simple jar, as a framework. So as other jars, you can just use it. You can package it within your application. The thing, and that works in any environment. So what we just did is a pure Java. So it just new standalone in-memory process configuration. We don't have any dependency on Spring or something like that there, but you can use Spring in order to start up the engine. Okay, we'll see that on the next step. Or you can use a Java EE Enterprise Edition, Java EE, so the Enterprise Edition, like a CDI, a startup CDI bean or whatever, and you can use OSGI containers or Karaf or whatever you like. The interesting part is always if you use the engine, somebody has to care about the life cycle. So you have to start up the engine and you have to shut down the engine afterwards. So basically, what I did in the simple Java program here, I started the engine. So this has to be done somewhere in the life cycle of your application. So that could be maybe done with a Spring, for example. So what you can do, I switched to Spring implementation. There in the test, I have an application context. So that's a Spring application context. If you don't know Spring, that doesn't matter at the moment. I think that's pretty straightforward to get the idea. But what we do here is we have the data source, we have a transaction manager, we have a process engine configuration. And that's basically the class I showed you earlier. And we use that in order to start up our engine. Now, the life cycle of the engine is basically taken care of by Spring. So if I use, again, if I do a programmatic startup, what I now do is I basically get the application context. That's what Spring does for me. Then I get the process engine from Spring. Okay. Then I do basically the same stuff. I create the deployment, I start a new process instance. And then if I close the context, the engine is basically shut down again. Okay, so let's see that. Sorry, run as Java application. You see the engine is started up. We see our process instance is started. And on the close, you see, for example, that the job executors shut down and all these kind of things. So the engine itself is shut down again. Okay. So this is something you could leverage in a Spring environment, for example. In CDI, you could use a startup bean or a singleton bean or whatever. Okay. The interesting thing is somebody has to take care of starting the engine and shutting it down later on. Then you can embed it in whatever environment you like. That's pretty straightforward. The most popular ones are Spring and Java EE, obviously. We don't use OCI that often lately. Okay, so yeah, best supported Spring and Java EE. Next interesting part is if you look at that process application, so you're basically putting the process engine inside your process application, your WAR deployment. Okay, we can, for example, do that with Spring. So what I could do here, I have the same application context within my web application. I configured my web application to use Spring. Spring now starts up my engine. Okay. And basically, I don't have any other stuff. I just have my Twitter thing here. And one interesting example, my Twitter demo, you remember the Twitter demo from the overview I have? In the publish on Twitter, I have my delegate tweet adapter. And in this case, this is a simple Spring Bean. Okay, so I have some own Spring Beans. You should scan for them, and I annotated them with a Spring component. Okay, this is how it works here. Within the application context, again, I configure data source and all that stuff. If I run that one, install. So let's build. I copy that one. Use my JBoss. I remove the Twitter bar from the overview. Let's see, JBoss should undeploy that. Yeah, I copy the one just had with the Spring. Okay, that starts up. And there's one interesting thing to notice here. What I did now in that war, okay, I added Spring and I added the engine itself. Okay, so the engine is part of the deployment. So again, if you look at the PowerPoint slide, the jar is part of my war. Okay, that war starts up an own engine. By using Spring, it starts up an own engine. So this will really, yeah, be embedded into the application. So I will not be able to use the web applications within my JBoss because they look into a different engine. We will see that in a minute. Okay, just let me finish the example. Let's see that. So the engine started. What I did actually in order to start or to talk to that application, I created a small web service. That's pretty straightforward again. So I have a web service which gets the process engine from Spring and has a couple of methods in order to start a new process instance if I have a tweet written, to get the tasks from the engine, and to complete the review task later on. Okay. Again, this is pretty straightforward. It's a good example, actually, what happens pretty often that you have your own API on top of our generic process engine API. You have your own domain-specific API in order to get it running. Okay, so I have a web service running. It's actually pretty nice in JMOS. It's in the Avid Java E container. It's really easy to get a web service. So I can use SOAP UI in order to access that. Okay. So I have a look in the engine. Get all tasks. No tasks. That makes sense. It's an empty engine. I say tweet written. So hello from Spring demo. That works. I get to my task list. The task list shows my review tweet for the content hello from Spring demo. That makes sense. I get the task idea and complete the task. There I need the task ID and prove true. Okay. So turn that up. That worked. So I should see my tweet live on Twitter. Yes, that worked as well. Nice. Okay, so I basically have one normal war. There's nothing Camunda specific in there. It's Spring and it starts with an engine, and that's basically pretty easy. Okay, if you do that, the interesting thing is if you build one application, it might be fine. If you build your next application, you already start to duplicate the engine. So any deployment you have might include its own process engine. And this might even mean that you have multiple databases. Every engine has its own database. And this is actually not a really nice scenario if you deploy a lot of applications. And it's also a problem if you want to monitor the process engine within one application. So let me show the alternative, what we do with the so-called shared process engine, what I used in the overview already. There we run the process engine as part of the container. So in my JBoss, already one of the process engine is already started during startup of the container. And this is used by the process applications, and the process applications don't bring their own process engine. So they just use the one within the container. Yeah. So that's an interesting difference. Yeah. I hope that somehow gets clear. If you look at it in the example, so here in the embedded Spring part, in the war, I have the engine as part of the deployment here. And in the one from the overview, yeah, there, if I look at that, I don't have the engine as part of the libs. Okay. Here, I use a couple of things additionally, which I don't need in the embedded case. So that's a processes XML file. And there's a second thing, which is the so-called process application class. So how does that work? So we look at the that one. We have the container, we have the process engine. By the way, we support most of the major containers. So it's Tomcat for the Java SE guys. It's JBoss, it's Glassfish, it's WebSphere, and it's WebLogic for the Java E guys. Okay, we're currently working on Karaf in the community, and basically that's it. Okay, and that's actually not it's yeah, not really rocket science. It's pretty straightforward. So the engine is part of the container, and we have that add process application class. And this basically talks to the central process engine. So during a startup of that class, we register this process application on the process engine. We deploy the BPMN 2.0 processes on the engine if they are not already deployed. And we keep like an in-memory table within the process engine where we know, okay, this process definition is within process application 1, and this process, BPMN 2 process is part of process application 2. Okay, and this allows the process engine to do something we call a context switch. So if the process engine runs, let's say, through a service task, it doesn't execute the service task within the context of the process engine, but it does a callback basically into that deployment. So we run in the class loader of that application, in the security context and these kind of things, in that string context, in that CDI context. So we do a full context switch here. And this makes it really easy to deploy multiple process applications, but use the same process engine still. And this has a couple of advantages, actually. One really, really easy thing is that we can use always a central monitoring tool now. So, for example, if I start a new tweet within my engine in the embedded use case, I basically did something like I deployed a war, but here I have a second engine within. So I don't see that process. If I now look into my cockpit on JBoss, now I look into the Twitter process. There's an old one running. I don't see my time at the moment, so let's cancel that one, just to make sure we don't have any running here. Okay, and let's start another one, and we'll refresh here. And I don't see any running process instance. Why? Because I'm looking at the engine in my container in my JBoss, and I deployed a Spring application running its own engine. Okay, and I cannot easily, if I do the model, if I do that model, I cannot easily deploy one monitoring application looking at all the engines. Okay, it's not impossible, but it's not easily doable out of the box. So this is, for example, something which is different. What we call a shared process engine, part of the container. Yeah. If you want to know more about how the process application works, it's actually not rocket science. So what we basically use, we leverage the environment in order to get a hook in the life cycle. So it might be a servlet context listener. So we have started, if the war is started, or in the CDI case, might be a startup, EJB in the Java E case, sorry. It might be even a Spring Bean. That's actually not that hard. So if you look at the Twitter servlet process application here, okay, and we have a look at the service process application, it's basically a servlet context listener. So it gets started when the war is deployed, and then it talks to the central engine. Okay. Again, if I undeploy the Spring stuff and deploy that one again, you will see that, sorry, delete the marker file for JBoss, picks it up. Yeah, it's deployed again, and it makes all the logging from the central engine. Now, if we look back to the Spring stuff here, it doesn't do that logging because it started its own engine. Okay, that's a pretty important difference. What we call the shared process engine. Hopefully that gets a bit clear here. There's a third mode we could start the engine in, which is what we call the remote process engine or standalone server. And that's actually the or pretty common approach for other vendors of BPM suites. So they basically start an own server and they communicate for everything remotely. So that's basically possible with Camunda BPM as well. So you can start up a container like the JBoss or Tomcat or whatever, and then you have the REST API, and basically you have other applications talking to your process engine via REST, and you do the callback via REST or SOAP, whatever as well. It's actually not the scenario we are best at. I mean, we're currently in the 7.2. We're building infrastructure to calling web services, SOAP or REST, and from the process engine more easy. So that gets easier in the 7.2, but it's still the approach where for us, all the advantages you normally have from the Camunda BPM, the Java developer friendliness, the integration into transactions, the really slow overhead, easy to set up, easy to run, a lot of these advantages you don't get in this scenario. So basically, if you compare the three, so we have the embedded process engine, so the first part of your deployment, you control the lifecycle yourself, okay? You have the shared process engine. The process engine is started with from the container. The lifecycle is controlled by the container. The process application just connects to your central engine. Or you have the remote process engine where you talk remotely to the engine. So if you compare them, what we normally recommend is to use the shared process engine whenever possible. Okay, that's the rule of thumb. Because it's easy to configure, you configure it once in the server. You might even use the pre-configured one. You can use the a very easy configured engine for all the test cases for your local development environment, and you can use a completely different setup for production environment. You don't see any difference in your VOR. The VOR might even be the same if you deploy locally on Tomcat and remotely on WebSphere, something like that. So it's really easy to use, to configure. It's easy to use. You don't have to set up or control the life cycle, and that makes it even easy to support. So if you have any questions on it, either in the enterprise subscription support or in the forum, it's much easier to support because it's a default or defined environment. Yeah, and it just feels right for what we do because it's the same model as Java uses for other stuff. So the container provides you with JPA or transactions or web services. Why should you bring your own workflow engine? It should be part of the container. Okay, but you might want to use the embedded engine. There are basically two default use cases when you do that. You want to ship it within a self-contained application. So you're a vendor, you want to ship your own application and basically a VOR, and you want to ship that one VOR. So everything should be contained within that VOR. Then it might be a good idea to include Camunda BPM there. And if you cannot change the container, so sometimes you have a prepackaged Tomcat or JBoss, and that's a default for the whole company. You're not allowed to do any shared labs or any other deployment, any modules. Then you cannot use these shared processes. There's maybe a third, but not so common use case. Sometimes you want to have different deployments on the same container using different versions of the engine. Then you should use the embedded engine as well. But I normally would not recommend to do that. And the standalone remote engine, as I mentioned earlier, if you can avoid it, we normally avoid it. It's more complex to run. You have different components, more complex to test, to operate. You have remoting, which is more overhead. And one of the big things, it's not transactional. You have to take care of a lot of things yourself. So it's much harder to end. But it might be interesting if you run a SOA with an ESB in your environment, which is web service based, and you only want to orchestrate these services. Then this might be a mode to run, and this doesn't have to be an either or decision. Maybe you run the shared process engine and deploy small process applications, basically just providing web services or calling web services, because you run in this mode calling a lot of services, but it might be done or provided by a shared process engine. So this is not completely either or decision. Okay. I would love to discuss these possibilities we have within our weekly live meeting. So basically get in touch with that, what you see here, test it yourself, and then discuss it in the online meeting. Okay, what's your preferred environment, what fits in your case. Okay, there's one example architecture I wanted to sketch here. This is something we see very often, and there are a lot of things here which might be a bit different for your application. Yeah, you have normally you have the shared process engine. You have that, as, for example, in JBoss. If you have JBoss, you might have different nodes, so you have at least a failover. That's actually not a problem. We have clustering on the next slide. So the engine just uses a shared database, all the state is in the database, so we can easily cluster there, no problem. You don't need anything on the Camunda process engine level. Then we have normally a couple of process application wars. So you normally separate the deployments for different domains. So we might have the procurement processes, we might have the order management process, and you might even have some global reusable processes like input management or whatever, sending some documents or sending some emails or whatever you have a process here. So you might want to separate them. So you have different deployments. You can redeploy them differently. So that works pretty well. You might have an own war for a generic user interface. That's pretty common. So that might be a task list, some global forms or whatever you might have here. And then it gets interesting how this user interface shows forms from your domain deployments. So that might be that you switch the web applications. That's something I did in the overview. I'm not sure if you noticed. So I go to the task list, which is the generic one. And I start a Twitter demo process where I use JSF form. Okay, if you look at the URL, currently I'm in the Camunda web app. If I go to the form, I'm now in the Twitter web app. So what I just did, I switched the context. That's one possibility you have here that normally imposes some requirements, some single sign-on. So somebody signed on here doesn't have to sign on again. That's one possibility. Another possibility might be that you include some form like HTML snippets or other stuff, which you load and display within that context. Okay, so that's pretty common to do. And you could even include these forms from the different deployments within one generic user interface. We have that sometimes. It has the advantage that the user interface itself contains one deployment. You don't have to fiddle with a single sign-on or other stuff, but it has the disadvantage that if any of the process changes its UI, you have to redeploy the generic user interface. Okay. Then we have the Camunda web app. That's normally a different deployment. You might not use a task list, but you might want to use a cockpit, the monitoring. So that's deployed. It uses the central shared engine, so that if you do something here, it always works because we do the context switch within the right process application. That's pretty cool. You might want to use or deploy an own BPM service more. We have that pretty often actually, that the people want to build their own BPM service, which is still generic, for not specific to any process, but it's specific for the customer. So you might, or you do not want to expose all the API we have in the process engine. So only a couple of methods, and this might be in the technology you prefer. So it might be a SOAP implementation, or it might even be JMS for the callback or these kind of things. So that's a pretty thin deployment normally, but it basically maps the stuff to your environment. Yeah, if you want to call other services, SOAP, REST, or you want to call your ESB, we normally deploy small delegates, which then call the web service. So that's a small Java delegate using whatever Apache CSAF or something like that to call that service. Okay, and the callback might be done within the BPM service. Okay, then you normally have a load balancer in order to get the different nodes running. Yo, pretty straightforward, works really well. Okay. If you plan something completely different, let me know. Ask in the live session. Send me a mail with a picture or whatever. We can discuss that. I'm always happy to discuss your architecture within the live meeting. Okay. Yeah, and I already talked about clustering, so that's easy possible. Okay, so basically it's done via the database. We don't cache any runtime data. We only cache static data. So the process definition gets cached, but not the process instance, for example. So you can, with the load balancer, it doesn't matter on which of the nodes you basically are routed to. Okay, that works pretty easy. The job executor, you remember the job executor from the beginning, the active component, which basically checks if there are timers to do, normally then runs on any node. And we have a mechanism to, with a log column in the database, to basically that the node who wants to execute the job logs it. Only if he gets the log, it really executes it. So basically the jobs are shared between the nodes, and you have some kind of load balancing there automatically built in. If you have more than 2 or 3 cluster nodes, it might get a bit interesting to configure the job executors that they don't step on each other's toes all the time, but that's pretty advanced already. Normal is that you have 2 or 3 nodes, and then everything works fine out of the box. Okay. There's one really interesting thing. You can use heterogeneous clusters there. So if you have different cluster nodes, they might have different process applications. So here we had the example from the beginning. So we have, for example, the reusable global processes, okay, on both nodes. But we might have the procurement deployment only on node 1 and the order management only on node 2. But they still have the same shared database. And how does that work? It works because what I said earlier, we register the process application on the shared engine. So this engine knows, oh, I know the order management processes. So I only take the processes I know, or I only execute the timers or jobs for the processes I know here. So this one will not touch any procurement processes, and the other way around. So this works pretty well. The thing you have to take care of is that the load balance, or if, for example, you call some UI here, and this is part of the deployment, then you might route it to, or you have to route it to the right application. So we can only take care of that if it's our thread, so if it's the job executor. But it works pretty well. Okay. And there's maybe one last remark here, which is really cool, actually. The last thing I want to show you, if you have a second deployment, a second process application, and I did a very easy one here with a call activity. You will learn that in the BPMN module, but a call activity calls a sub-process, a reusable sub-process. In my case, I want to call the Twitter demo process in the latest version. And the Twitter demo process is part of a different WAR file. Okay. And I want to change something here quickly. So I skipped the review stuff. We have enough review, so I immediately want to publish the tweet. Okay. So what I do, I deploy that one. Wait a second. Yeah, I actually, yeah, doesn't matter. Yeah, that creates the test because I don't have the approved stuff, but I have something prepared here. I deploy it using a small ARM file, and that skips the test and copies the stuff into my JavaS. And I do the same stuff for that client application here. Second WAR file. So my JavaS picked up the Twitter demo process and the Twitter process client. Everything's fine. There are 2 different process applications. Okay. And what I can do now, if I go to the task list, if I start the Twitter demo process client, there's something, by the way, if we don't have a UI, we use a generic form. So I could add whatever variable I need, some X, Y, Z, hello, and so on. Start. It was started. I don't get any error. I don't get any user task because I skipped that, but we can check in cockpit. I go to the Twitter demo process, look in the history. I see there's one process instance already ended. Okay. It walked through the publish on Twitter. And I should see a new tweet. Yeah, that one. Where the content is coming from is actually a small secret from my side. No, it's really straightforward. I handed over some data here. So I said tweet from, and now I have the process instance ID added there, and I pass that as a variable content to my other process. So this is how that works. But the really cool thing here is that when we call the call activity, we change the process application. So if I go back to that image, we basically started within one application, one war. Okay, so we started the BPMN file here on that engine, and then we basically switched the context to the other one because the tweet delegate was a string bean or a CDI bean, sorry, within the other application. Okay, so we can really switch the applications here magically in the background, and that's something we take care of. Okay, basically that's it for the architecture at the moment. I would be happy if you join the live meeting, have some questions or discussions ready. In order to play around with it, I think you're already fully equipped. You have your JBoss running, you have your Twitter application running, so you can play around with that, play around with our different process applications, maybe communicating between them. Have fun with that, and see you next time.